Let's look at fixed costs and the impact they have on unit cost. As you spread your fixed costs over more and more units, the total cost per unit drops. Let me give you this example. Assume that total monthly costs are $1,000 and that your variable cost per unit is $10. So if we produce just one unit, the variable cost of that unit would be $10, and we would have to assign all $1,000 of the fixed cost to that unit. So the total cost of that unit would be $1,010. If we produce 10 units, the variable cost per unit would be $10, but now we divide the $1,000 by 10, so assign $100 of fixed cost to each unit, so the total cost of a unit is now $110. If we produced 100 units, the variable cost would be $10, and then we would divide the $1,000 by 100 and assign $10 of fixed cost, so the total cost would now be $20. Now let me pose a question to you. What would be the total cost of a unit if we produced 1,000 units? I'm sure you're going to tell me that the variable cost would be $10, the fixed cost would be $1, and so the total cost would be $11. Now this phenomenon will continue until such times as we have to add additional fixed costs, and then they will reverse itself and the total cost per unit will go up. And then again, as we increase our production, the total cost per unit will drop. In lecture number 13, you'll see a graphic representation of the impact of this phenomenon on the break-even analysis. So we use the term to say fixed costs are fixed over a relative range. So what is a relative range? As I mentioned before, it could be 6 months, it could be a year, it could be 2 years. It's that time period over which we do not increase our fixed cost. Another type of cost we need to talk about is an opportunity cost. An opportunity cost is an oxymoron. An opportunity cost is the benefit foregone by choosing one course of action over another. Let me give you an example. Let's assume you can make one product, but you have the opportunity to make two products. You can make either A or product B, but not both. So if you choose to make product A, then the profit that you could make on product B is foregone, and that is called an opportunity cost. And there are places in managerial accounting where we do apply opportunity costs. One I can think of, which we don't discuss in this course, is called make-buy decisions. Now let's address mixed costs and cost estimations. A mixed cost is a cost that contains both a fixed and variable component. Approximately 70% of all your manufacturing and administrative overhead consists of mixed costs. Now, it is critical that we understand the fixed and variable components of a mixed cost. This is particularly true in the budgeting process because we want to be very accurate in our budget. So we have to know how much of our projected cost is fixed and how much is variable. Let me give an example of a variable cost. Utilities is a very good one. You live in an all-electric house or all-electric apartment. It comes Christmas vacation, and you're leaving on a 2-week trip. The last thing you probably do as you go out the door is to shut off the lights. But the thing you do just before that, or maybe after, is you turn down the thermostat to a level at which it would be uncomfortable if you were living in the residence, but is high enough to keep the pipes from freezing. So you're gone for 2 weeks. You come back. The first thing you do is turn up the thermostat. Then you may walk into the laundry room and dump out your dirty clothes out of the suitcase and throw them in the washer and ultimately into a dryer, and then you walk out in the kitchen and oh, lo and behold, you're left with a sink full of dirty dishes. I know you wouldn't do that, but let's say you did. So you're going to load those in the dishwasher, and so all of a sudden you're using a lot of electricity. If you were to go outside while you were gone and look at the meter, it'd be moving very, very slowly. If you go outside after you return and you've started all these electrical appliances, it'd be going very, very fast. The speed at which it moved while you were gone is a fixed proportion of the utilities cost. The difference between the speed that is going now and when you were away is the variable portion. And I'm sure if you called an engineer from Idaho Power Company, they could come out and measure that for you in terms of kilowatts. And then you could cost it out. There are two features of a mixed cost that are important to us: the cost driver and the cost pool. The cost driver is what drives the cost. Labor hours, machine hours, patient days, number of procedures. In the case of the all-electric residence, it could be the number of people living in that particular residence. It's usually an absolute number, not a dollar. The cost is a cost pool, the utilities cost, supplies cost, something of that nature. So the cost driver drives the cost of the dollars in the pool. Now the total cost is fixed cost plus number of drivers times the variable rate. So if you separate the fixed and variable cost, then you can make a projection by taking the fixed cost component and the variable rate amount and multiply the variable rate by the number of projected drivers and get the total projected cost. Now we can use Excel to separate fixed and variable components of a mixed cost. And in this module I have posted a PowerPoint slide that explains how you can actually go into Excel and the add-ins and add in this particular regression package so you could use it in separating fixed and variable costs in a mixed cost situation. We have a hotel. Our cost driver is days of occupancy. Then we are comparing that to our cleaning supplies. Now, we would have cleaning supplies even if we had no residents in the hotel, because we still have to keep certain common areas clean. Now, we want to take this information and we want to separate out the fixed and variable components of the supplies cost. So we use historical information to do this. Now, you need to be very careful in doing this type of projection that the information you're using is predictable of the future, that you don't have something different that's going to occur in your operation. If it does, then this is probably not a good predictor. But if, in most cases, in a consistent situation, you can use historical information to project the future. Now this is what it looks like when you calculate the mixed cost using Excel. You'll get this kind of a screen or printout. There are only 4 numbers on here that I'm really interested in. This is not a stat class, so I'm not going to get into a lot of detail about standard errors and so forth. First, let's look at the multiple R. This is the coefficient of correlation. This tells you to what extent there is a relationship between the cost driver and the cost pool. And the nearer it gets to 1, the more perfect it is. So a positive 1 would be a perfect correlation, which would be very unusual to find, and a negative 1 means there's no correlation. Here it looks like we have a pretty strong correlation, 0.98%. R squared, which is a function of the multiple R, tells you what percentage of the time a change in the independent variable causes a change in the dependent variable. Now, the independent variable is the cost driver, the dependent variable is the cost pool. Down at the very bottom, you're going to see two coefficients. One says intercept. This is the fixed cost. This would be the cost of cleaning supplies if you had no one staying at the hotel. And then for every day of occupancy, you have 77 cents of variable cost. So, let's say you're projecting 1,000 occupancy days next month. Your variable cost would then be 77 cents times 1,000, or $7,000. Your fixed cost would be $3,973. So the total cost would be $11,673. Let me go over that again. The variable cost, assuming you're going to have 1,000 occupancy days, would be 77 cents times each day, or $7,700. Then to get the total cost, you add to that the fixed cost of $3,973, and so the total projected cost of cleaning supplies next month, assuming 1,000 days, would be $11,677.